Hello everyone and welcome back to the course Building Construction Technology. Myself Preeti Singh Patel, Civil Department from Mahatma Gandhi Institute of Technical Education and Research Center, NAVSARI. These are the content which I am covering in this video lecture. Introduction, types of foundation, precautions for foundation in black cotton soil, type of foundation in black cotton soil, causes of failure of foundation and setting out foundation trenches. So let's start the topic. First of all, what is foundation? The foundation is the lowest part of the structure located below ground level which transmit the load of the superstructure to the soil safely or without any shear failure. It is directly contact with the subsoil. Lowest portion of the foundation called footing. Next, purpose of foundation. The first purpose is distribute the structural load to the soil safely. Second, provide stability against sliding and overturning. Third, minimize differential settlement in soil. Next, provide safety against undermining. Next, provide level surface for the construction of the superstructure. Next, minimize de-stress against soil movement. There are two types of foundation, or foundation may be classified into two types: shallow foundation and deep foundation. So first of all, what is shallow foundation? According to Terzaghi, a foundation is shallow if its depth is equal or less than its width. In this figure, you can see the image of foundation. If the depth of the foundation, which is D, is equal or less than of the width of the foundation or the footing, is known as shallow foundation. What is deep foundation? If the depth of the foundation is more than the width of the footing, is known as deep foundation. For example, if the depth is 1.5 and the width of the footing is also a 1.5, then it is termed as shallow foundation. And if the depth is 2 meter and the width of the foundation is 1.5, it is termed as deep foundation. So shallow foundation, according to the design or from the design point of view, can be classified into four categories: spread footing, combined footing, strap footing, mat or raft foundation. And deep foundation may be classified into a three type: pile foundation, a caisson or well foundation, or coffer dam. First of all, what is spread footing or foundation? The spread footing are those which spread the superimposed load of wall or column over a large area. It may be column footing or wall footing. So next is type of spread footing. There are three types of spread footing. First is wall footing, second column footing, third grillage foundation. In wall footing, simple wall footing, stepped wall footing, then single column footing for a column, step footing for a column, and next is slope footing for a column. So let's start simple wall footing. A simple wall footing or a strip footing is a continuous strip of concrete that serves to spread the weight of load bearing wall across an area of soil. Spread footing, simple wall footing are used when the load of the structure is low and the safe bearing pressure of the soil is heavy. Step wall footing are used when the load of the structure is high and the safe bearing pressure of the soil is low. Then the step wall footing are used. In step wall footing, a masonry offset, this masonry offsets are provided to spread the load over a large area. This is the image for simple wall footing and step wall footing. In this image you can see there is a wall and PCC slab, precast concrete slab. For step wall footing, first layer is precast concrete slab, then masonry layer, then second masonry layer, then third masonry layer, then wall provided. Next is column footing. Column footing are provided to transfer the load of individual column to safely without any failure. These are generally made from reinforced cement concrete. The footing may be simple, sloped or stepped depending upon the requirement of the load transferred and the bearing capacity of the soil. If the bearing capacity of the soil is high and the load of the structure is low, then the simple footing can be used. If the load of the structure is moderate and the bearing capacity of the soil is not that much high, that slope footing can be or step footing can be used. Okay. The shape of the footing may be square, rectangular or circular. When heavy load has to be transferred and spacing of column is less, column footing is replaced by combined footing. This is the image of sloped column footing. You can see in this image there is providing some slope. Next, this is an image for simple column footing and this is for stepped column footing. This is also image for step footing, slope footing and simple footing for a column. Next is grillage foundation. Grillage foundation is an isolated footing provided when heavy structural load from column, piers or steel section are required to be transferred and the soil bearing capacity is low or poor. This type of foundation is light and more economical, for which deep excavation is not required and provide more area at the base so that the intensity of pressure can be reduced within safe bearing capacity of soil. It can be classified into two categories: steel grillage foundation and timber grillage foundation. So first, timber grillage foundation. This type of foundation is provided for heavily loaded masonry walls or timber column. This foundation is especially useful in waterlogged area where the bearing capacity of soil is very low or the loading of the soil is limited to 50 to 60 kilonewton per meter square. The foundation used timber planks and timber beams in the place of steel. No concrete is required in timber grillage foundation. In this figure, you can see the section and the plan of timber grillage foundation. In this figure, you can see first in this figure you can see the section and plan. The construction of timber grillage foundation is first the excavation for foundation is done to the desired depth and the base is leveled. Then the bottom layer of timber plank of size 20 to 30 meter wide and 5 to 7.5 centimeter thick is laid side by side without any gap between them. You can see there is no gap between the planks. Over this platform, a tier of wooden beam is laid at a right angle of the direction of this plank. You can see over the top of this layer, a timber beam of same section as that of wooden post is placed at a right angle. Then the timber post is then fixed vertically to the timber beam, and then the foundation for the wall is constructed. Next is steel grillage foundation. Steel grillage foundation consists of steel joist or steel beams which are provided in single or double tiers. Such column, in case of double tier grillage, the top tier is laid at right angles to the bottom tier. The beam of each tier are held in position with dia space bar or dia pipe separator. The grillage beam embedded in concrete. What are the method of construction for steel grillage foundation? First, the excavation for foundation is done to be a desired depth and the bed is well leveled. Then the foundation bed is then covered with 15 centimeter thick rich mix of concrete which is well compacted to make it impervious. You can see in this image 15 centimeter thick layer of concrete. Then the grillage beams are then placed on this bed at specific distance using separator. This separator. The top surface of grillage beam is kept in horizontal plane and rich cement ground is filled all around the lower flange of the beam to secure them to the concrete bed. Then the concrete is placed between the around the beam. Then second tier of beam is then placed at right angle to the first tier, and the entire space is filled with concrete. This and the steel section is then erected on the base plate. This is base plate fixed on the second tier beam with the help of sides angle and gusset plate. These connecting elements are also embedded in the concrete so that the joint becomes rigid. This is also the image for steel grillage foundation. First concrete pad, then steel beam, then steel joist, then again steel beam, steel joist, then base plate, and then steel section. Next is raft or mat foundation. It is generally a combined footing that covers entire area below the structure to support the load of column and wall. Mat foundation is used when the safe bearing pressure of the soil is low and the spread footing covers large area of strata. Then it is economical to provide raft or mat foundation. Next condition, when the soil mass contain compressible lenses or the soil is sufficiently erratic so that the differential settlement would be difficult to control. So the mat or raft foundation eliminate the differential settlement into the soil. Also, a raft foundation is used when the soil is highly compressible soil. This is the image of raft or mat foundation. This is the section of mat or raft foundation. This is the plan. In this plan, this is square portion is a column or wall. This is the actual image of mat or raft foundation. You can see there is a complete concrete slab for the entire structure, and this is column. Next is combined footing. Combined footing is a single footing which supports two columns. A combined footing is provided under the following circumstances. when the columns are very near to each other and the footing overlap each other. Next, when the safe bearing pressure of soil is less and require more area if isolated footing is provided. Next condition, when and column are located near property line and isolated footing projects beyond the property line. A combined footing may be a rectangular or trapezoidal in plan. The aim of combined footing is to get uniform distribution, a uniform pressure distribution under the footing. But while using this type of footing, one should keep in mind that the center of gravity of footing coincide with the center of gravity of a combined load from the column. Also, when the column located at the property line and carry heavy load, then trapezoidal footing must provided to achieve above mentioned mechanism. This is the image of combined footing. You can see both the column have single footing. This is the actual image of combined footing. Next is strap footing. A strap footing consists of when two or more footing of individual column connected by a strap or beam. What is strap footing? When two or more column footing connected by a strap is known as strap footing. Strap footing is required when a column is near to next the adjacent property limit, or a square or rectangular footing concentrated loaded under the column would extend to the adjoining property, which may not be possible. In that case, the strap footing may be provided. In strap footing, that strap beam only connect the two column, does not remain in contact with the soil and does not carry any load and transfer any pressure to the soil. The main function of this strap is to transfer the load of heavily loaded outer column to the inner one. This is the actual image of strap footing. You can see in this image there is the footing reinforcement. There is a footing, this is column, there is a strap, a connecting beam or a lever, and a connecting beam reinforcement. Then another footing reinforcement and footing. Next topic, foundation in black cotton soil. Construction of building on black cotton soil or expensive soil is very much dangerous due to its volumetric change with the change of atmospheric condition. When the black cotton soil becomes wet, it will swell excessively, and when it becomes dry, it will shrink excessively. Thus, the black cotton soil is highly sensitive to water. Due to the presence of fine clay particles, the black cotton soil will swell when it's come in contact with water, and the differential settlement of the building causes by the movement of ground due to the alternate swelling and shrinkage result in formation of crack. So what kind of precaution we have to take during the construction on black cotton soil? The first precaution is the foundation should be taken to such depth where the crack cease or the uh, where the crack cease to extend. The minimum depth of foundation should be 1.5 meter. Next, the maximum load on black cotton soil should be limited. If the load on the soil should be limited, then any kind of foundation can use for black cotton soil. Next, the main wall of the building must be provided with all round reinforced concrete ties and band. Next, in case the depth of black cotton soil is up to 1 meter to 1.5 meter, then completely remove the entire soil and place the foundation below that depth. As much as possible, avoid direct contact of black cotton soil with the foundation material. This can be achieved by making wider trenches and filling spaces on either side of the foundation by masonry with sand and muram. In case of important structure, raft foundation should be provided. For less important structure, the foundation should preferably taken at least 15 centimeter below the depth. Or construction may be done in dry season, and under-reamed pile foundation is also a good choice for foundation in black cotton soil. So which type of foundation is provided in black cotton soil? There are three type of foundation we can provide in black cotton soil. First is strip or ped foundation, second pier foundation, and third under-reamed pile foundation. So first is strip or ped foundation. The strip foundation for wall and the ped foundation for column may be provided for medium load. When the soil pressure are relatively large, alternate layer of muram and sand are provided, which will act as a spring and can compress or expand with the subsoil movement. When the soil swells, the sand grains would yield by moving up and thus relieving the swelling pressure. When the soil shrinks, the sand layer would expand, but there will be no discontinuity in the soil support. In first image, you can see in between the concrete slab and uh, in this figure you can see a 60 centimeter thick layer of sand is provided to avoid the direct contact between the foundation and the soil. Next, where the soiling pressure are relatively high, the alternative layer of muram and sand are provided, which will act as a spring. In second figure you can see a layer of muram and sand is provided to avoid the direct contact between the foundation and the soil. If the soil is soft or having poor bearing capacity, a 30 centimeter thick layer of ballast and muram should be provided and rammed. Then 30 centimeter thick layer of coarse sand may be provided. In this figure you can see a 30 centimeter thick layer of muram and ballast, then 30 centimeter thick layer of sand is provided to avoid the direct contact between the foundation and the soil. When the soil is having high swelling pressure and high shrinkage properties, after compacting the base of trench 25 to 30 centimeter wide and 25 to 30 centimeter thick strip concrete are laid and compacted on both sides of the sand. In this figure you can see is filled in the middle. Above this the foundation concrete is laid. If the soil is high swelling pressure, then this type of arrangement may be done. The side of the masonry footing are filled with sand and also 80 centimeter dia pipe, this pipe with plug are placed through masonry and concrete bed up to the bottom sand filled to pour the sand if required. Next topic, pier foundation. For the wall who carry heavy load, the pier foundation with arches may be provided. The piers are dug at a regular interval and filled with concrete. This is the pier. which are connected by a concrete or masonry arch, and the wall may be constructed over the arch. The arches are constructed with the gap above the ground level, which may permit the movement of soil during the swelling and shrinkage operation. Next, under ream pile, the pile foundation are provided inexpensive soil such as black cotton soil, filled up ground, and soil having poor bearing capacity. Under ream piles are bored cast in situ concrete pile of shallow depth having bulb shade enlargement near the base. In this type of foundation, the structure is anchored to the ground at a depth where ground movement due to changes in moisture content are negligible. The piles having one bulb known as a single underream or two or more bulb known as a multiple bulb underream pile. The piles are connected by a rigid capping being suitably reinforced over which the wall is constructed. The vertical spacing between two walls is vary from 1.25 to 1.5 times diameter of bulb. For black cotton soil, the bulb is increasing bearing capacity and also provide anchor against uplift. This is the image of underream pile. There is enlarged area, lower portion of the pile. This is bulb. If one bulb is provided in the pile is known as single bulb underream pile. If number of bulb is provided, then it is known as multiple bulb underream pile. This is the actual image of underream pile. Causes of failure of foundation. The causes of failure of foundation are many because of many reasons. The first reason is poor drainage facility. If the poor drainage condition around your foundation can causes the oversaturation of the soil, which causes instability around the foundation. So how can we avoid the settlement of the soil? Providing proper drainage facility around the foundation area. Next, weather condition. Hot and dry condition may causes the soil around your home to shrink and pull away from the foundation. When this happens, cracks may appear throughout the structure and the shrinking soil will create gaps to the foundation, which allows to the foundation to sink and settle into the foundation. So how can we prevent the weather condition in foundation? By providing a limited load by by providing limited load on the soil, then foundation should be taken to a depth where the cracks may be ceased to extend. Poor soil condition or transpiration. Tree roots could dehydrate the soil beneath a home, causing soil shrinking and settlement of the home. Maturing trees and bushes close to a home or building is a common cause of foundation settlement. As the trees and bushes mature, their root system demand more water, and these roots will draw the moisture from beneath the home foundation and causes the soil to shrink. This result in the settlement of the foundation or the home. So how can we prevent? The providing safe distance between the trees and the foundation to avoid the damage due to the trees, or the foundation of the structure should be taken to a depth of at least 90 centimeter to minimize the cracking action. Next, plumbing leaks. Water from leaky plumbing is often a major contributor to a foundation problem. When excess water is present due to a plumbing leak, the soil supporting your foundation can erode. And moisture is added to the soil because of plumbing leak, the soil and foundation will move and causing foundation settlement or tilting or failure of the foundation. So how can we prevent failure of foundation? By providing proper plumbing near the foundation. Next, poor building site and ground preparation, cutting and filling situation where the soil is removed from part of the lot and stacked on another must have proper soil stabilization before the structure is constructed. Otherwise, unexpected movement of the soil beneath the foundation may occur. If the builder failed to prepare the soil before your home foundation was poured, it can cause foundation settlement. Soft, low density soil and improperly compacted soil beneath a foundation is one of the leading causes of foundation failure. The grading of the soil should always divert water away from your home to that the water is not allowed to seep under the foundation. Next, setting out foundation trenches. So setting out foundation trenches means the marking of the excavation line and center line on the ground before excavation is started. After the foundation design is done, a setting out plan, sometimes also known as foundation layout plan, is prepared at suitable scale. So the procedure of setting out foundation trenches: first, the center line of the longest outer wall of the building is marked by stretching a string between a wooden and mild steel peg driven at the end. This line serves as a reference line. Then the center line of the wall, which is perpendicular to the long wall, is marked by setting up a right angle, and the right angle is set up by forming triangle with side 3 and 4 unit long. If we fix the two sides of right angle triangle, then the third side should be taken. The dimension should be set out with a steel tape. The alternate method of setting out right angle is by the use of theodolite. Similarly, the outer lines of the foundation trenches of each cross wall can be set out, which are marked by stretching the string joining the corresponding peg at the two extremities of the line with the help of dry lime powder. Similar outer lines of the foundation trenches of each cross wall can be set out and shown in figure. Let's show you the video of setting out foundation trenches so you can easily understand how setting out foundation trenches can be done.
Center line method. Let us see about center line method for setting out a building. For setting out the foundation of small buildings, the center line of the longest outer wall of the building is first marked on the ground by stretching a string between wooden or mild steel pegs driven at the ends. This line serves as reference line. For accurate work, nails can be fixed at the center of the pegs. Two pegs, one on either side of the central peg, are driven at each end of the line. Each peg is equidistant from the central peg, and the distance between the outer pegs corresponds to the width of the foundation trench to be excavated. Each peg may project about 25 to 50 mm above ground level and may be driven at a distance of about 2 meters from the edge of excavation so that they are not disturbed. When string is stretched joining the corresponding pegs, that is 2 to 2 at the two extremities of the line, the boundary of the trench to be excavated can be marked on the ground with dry lime powder. The center line of other walls, which are perpendicular to the long wall, are then marked by setting out right angles.
This is the layout of setting out foundation trenching. Thank you for the listening.